So here you have to state the value of d from the given equation, and the equation is given to be x cubed plus bx squared plus cx then plus d equals 0. Alright, so and of course we can get the sum of the roots, which is summation alpha from here to be minus b, then summation alpha beta is going to be c, and product of the roots, which happens to be alpha, beta, and gamma, that's going to be minus z. Alright, now that we have this, and it is given already that alpha, beta, gamma is minus 1. So which means that minus 1 equals minus d here, and d equals 1. So the value of d is 1 actually. Then b, you need to find a cubic equation with coefficient in terms of b and c, whose roots are alpha plus 1, beta plus 1, and gamma plus 1. So we are trying to find a new equation that has these roots. So what we can do, first thing here, let's label this to be equation 1. Now to get that new equation, we can represent the roots to be y equals x plus 1, okay? And by doing this, we actually need to make x as the subject of formula here, which means x is going to be 1 minus y minus 1. Alright, so we call this to be equation 2. Now you can substitute equation 2 in 1 so that we can express everything in equation 1 in terms of x. And by substitution, equation 1 becomes y minus 1 cubed plus b y minus 1 squared plus c y minus 1 then plus d equals 0. Alright, so by expansion, this becomes y cubed minus 3y squared plus 3y then minus 1 then plus b. So the second bracket becomes y squared minus 2y plus 1, and the last one remains as y minus 1 then plus z equals 0. So we can expand everything there and write it in simplest form. So in simplest form, the equation is going to be y cubed plus b minus 3y squared plus 3 minus 2b plus cy then plus b minus c. Okay, sorry, this should be brackets. Let me close it very well. So this is closed brackets then equals 0. So this is the equation whose roots are alpha minus 1, beta minus 1, alpha plus 1, beta plus 1, and gamma plus 1. Now that we've established the fact that, okay, this is going to be the equation, so we can label that to be equation 3, because it's most likely that we are going to use that to determine or to find the last question here, where we are asked, where it is given that gamma plus 1 equals minus alpha minus 1, then you should deduce that this equals minus b. Okay, so what do we have to do, or what do you need to do in order for you to get that? Okay, first thing you need to do here is to find the sum of the roots, then sum of each pair of the roots, and product of the root of the new equation. Okay, so this is what I'm saying. Let's alpha substitute 1 equals alpha plus 1, then beta 1 equals beta plus 1, and gamma 1 equals gamma plus 1. So we can say that, okay, this equation that we obtain in equation 3 has root of alpha 1, beta 1, and gamma 1. Okay, if we've established that fact, now we can actually find some of the roots, which is alpha 1 plus beta 1 plus gamma 1, which means summation alpha 1, that will be minus b minus 3. Okay, that's the first equation here. So let's call this to be equation 1. And the second one, which is going to be sum of product of pairs of the roots, which is alpha 1, beta 1, alpha 1, gamma 1, and beta 1, gamma 1, which can be represented as alpha 1, beta 1. So that one now is going to be 3 minus 2b plus c. Okay, and the last one, which happens to be product of the roots, that's going to be C minus B. Okay, ordinarily it should be minus of whatever you have there, so we can write as C minus B. So let's call this to be equation 2 and this is equation 3. Now from equation 1, let me start from equation 1. From equation 1, we will have alpha 1 plus beta 1 plus gamma 1 equals minus B minus 3. So now we can represent this. We can substitute what we have as alpha 1 there, which is alpha plus 1. Then beta 1 is beta plus 1 and gamma 1 is gamma plus 1, which is 3 minus B. And of course, part of the condition to find C is that alpha plus 1 gamma plus 1 equals minus alpha minus 1. So we can remove alpha plus 1 here and replace it with we can remove gamma plus 1 and replace it with minus alpha minus 1. So this is alpha plus 1, beta plus 1, then minus alpha minus 1 equals 3 minus B. Okay, so of course this takes this, then you have B plus 1 equals 3 minus B, then eventually you obtain B equals 2 minus B. 2 minus B, or we can still leave it as either of the two. So let's call this to be equation 4. Okay, now from equation 2, what do we have there? Alpha 1 beta 1 alpha 1 gamma 1 then plus beta 1 gamma 1 equals what? 3 minus 2b plus c. So let's substitute what we have. The alpha 1 is alpha plus 1, then beta plus 1 plus alpha plus 1. And remember again, anywhere you see gamma plus 1, you put minus alpha minus 1. So but before then, gamma 1 same thing as gamma plus 1, then beta plus 1 and gamma plus 1 equals 3 minus 2b plus c. Okay, so this is alpha plus 1 beta plus 1. There is gamma plus 1 here. We can actually, what am I writing? So this should be gamma plus 1. So the gamma plus 1 here can be replaced with minus alpha minus 1, which is going to be minus alpha plus 1 squared. Then likewise what you have here, this should be alpha plus 1 then beta plus 1 equals 3 minus 2b plus c. So eventually this cancels this. Now you're left with minus alpha plus 1 squared equals 3 minus 2b plus c. Okay, so this is this. Let's call this to be equation 5. And the last equation, which is the product of the roots, so we can say from equation 3, where you have alpha 1 beta 1 gamma 1 equals c minus b. Okay, or b minus c, that way. So alpha 1 is alpha plus 1, beta 1 is beta plus 1, and gamma 1 is gamma plus 1 equals c minus b. Now we are going to remove gamma plus 1 and put minus alpha minus 1. So this becomes minus alpha plus 1 squared, then beta plus 1 equals c minus b. So this is equation 6. Now from equation 5, remember we've gotten value for minus alpha plus 1 squared to be this. So which is 3 minus 2b plus c. So we can just put that here in equation 4 and equation 6. And don't forget again, we also have beta plus 1 to be 3 minus b. So we substitute these two there. So for the minus alpha plus 1 squared, we have it to be 3 minus 2b plus c. Then for beta plus 1, we have that to be 3 minus b. Okay, then we have c minus b. But according to what we are to show for here, the answer should be B minus C, not C minus B. So apparently I think there is a mistake somewhere here, mistake somewhere here. So we need to figure that out. Okay, I think that's correct actually. So all we just have to do is write 3 minus B as minus, we can factorize minus, and we have 3 minus 2B plus C, and this is B minus 3. Okay, then C minus B, same thing as minus B minus C. So this takes this, then you finally have 3 minus B plus C, and B minus 3 now equals B minus C, and that is actually the final answer there. Okay.